Alright, I'm going to go over the opener that you just did. And basically that problem entailed you taking a graph that was in rectangular form and converting it into polar form. Now this graph here, we don't know the equation of it. It's not just a straight up sine or cosine. There's something else going on with it, but it doesn't matter. We can take any graph that's in rectangular form and convert it to polar form. And we kind of just go point by point. So the first thing to note is that this axis here is like the theta axis, and this is r. Okay? So the first point, r is 1 and theta is 0. So if I'm going to go down here, first of all, I need to go to this polar grid and I need to make a scale. I can see that the lowest I ever go in terms of r is -1, and the highest I go is 3. So I need to make a scale that would reflect that. So I'm going to make the scale like this. 1, I'm going to go every 3. 2, 3, like that, just so I have plenty of room. And so note that the 1 is this ring all the way around. The 2 is this. So I'm going to just go ahead and label that kind of all the way around, just so that it's easy to tell everywhere. Okay, so 1, 2, 3, and then here it's 1, 2, 3. Making that scale is really important. Okay, really important to do that. Just is going to prevent you from getting confused here. So the first point, theta, is 0, and r is 1. So that's pretty easy. That's right here. Okay. Now I can see that the second point, theta is pi over 4. So I'm talking about, this is our pi over 4. I'm talking about on that axis, essentially. And r is 3. Okay, so I'm on that yellow thing, which I just erased. And we're at 3, so we're up, let's see. Yeah, we're about right here. Okay. I like to put a few points and then sort of connect them. It's kind of hard to connect when you got them all going. So then now the next point is pi over 2, 1, so that would be right here. So this part of the graph kind of goes like that. Okay? Now we're going to turn around. I can see that because here 3 pi over 4, 2 would be right here. Okay? So now I'm going to go up like this. All right? And then we're at pi 1, so we're back here. Okay? And then now here's where it gets a little bit interesting. Between this point and this point is 5 pi over 4. That's theta, and r is -1. We're going to go through the pole. Okay? We're going to go through right here. Between here and the next point. So let's put that next point on here. 5 pi over 4 is right here. Okay? But we're -1. So -1 would be right, let's see, get myself confused. 1, 2, 3. Right there. Okay? So between this point and this point, we have to go through the pole. Okay, so basically what that means is we're going to go here and then there. Now where do we go exactly? How does this curve? It's not that easy to tell, but we need to go through that pole. Okay, so now the next point is 3 pi over 2, 1, which is right here. So now between this point and this point, we have to go through the pole. So we kind of loop around here, go through the pole, and end up right there. Okay. And then finally, our last point, actually not our last point, this point is 7 pi over 4, looks like 2. So that's going to be right here. So I go out here. And then finally, the last point is 2 pi 1, which is back where we started. And so we're going to go like that. Okay, so that's what that graph looks like. And you just kind of go point by point, and the hardest parts are when we go through, anytime we go through this x-axis, essentially, we have to go through the pole on this graph. And so you have to sort of say, well, where's this point, where's this point, plot those 2 points, and then figure out the path that would take you through the pole. Okay? All right, so that's number one. Now you're going to get another problem to do.